This lecture is about shifting and reflecting graphs of functions. Some of these graphs we're going to look at in pretty great detail a little later on. But another term used for this is transformations of graphs. And these are the three transformations that we're going to be looking at: vertical shifts, horizontal shifts, and reflections. Vertical shifts, I like to think of these as being outside. So it would be outside of the thing being squared or the square root of the absolute value. Those are the three functions that we're going to look at, are the quadratic, the square root, and the absolute value. And if you are adding some value, then you would shift up k units. If you're subtracting a value, you shift down k units. Horizontal, I like to think of these as being inside. And these work opposite of what you would normally think. So if you're adding some value inside, then it's left h units. If you're subtracting some value inside, then it's right h units. Reflecting, if you're multiplying all of your y values by a -1, then you're reflecting over the x-axis. If you're multiplying all your x values by a -1, then you're reflecting about the y-axis. There are three graphs that we're going to be doing these transformations on. The first one is the quadratic graph, and it basically looks like a big capital U. So this is how this graph looks, and the domain for this graph is always going to be -infinity to infinity. So it goes off to the left forever and off to the right forever. The range, if it's opening up, it's always going to be from this bottom point using a square bracket, and in this basic graph it's going to be 0, and then go up to positive infinity. So it starts here and goes up forever. Oh, and this is the graph for f of x equals x squared. And there's a pattern that you can use to get the points on this graph if you're asked to plot points. So from this bottom point, which on this graph is at 0, 0, you can move right 1 and up 1. And then go right 1 again. And then up 3. And then you can do the same thing over on the other side. So left 1, up 1, to get to another point, and then left 1, and then up 3. Okay, so you can use that pattern to plot points on that graph if you wish. The next graph is a square root graph, so it's a square root of x, and basically it's this graph flipped over on its side. Move this over a touch. Okay, so it starts at 0, 0, and again it's this graph flipped over on its side, so it's this part, only right here. So it's right there. And so you can use the pattern again if you want. Instead of going right and left, you're just going to go up 1. So from the basic point you go up 1, right 1, and then you would go up 1 more, and then right 3. Okay, and that will give you 3 points on this graph. Okay, and then the domain. So that's the x values. So we're starting right here, and it goes up forever. So that would be from 0 to infinity, and we include 0 in that because it's included on the graph there. And then the range. So there is no graph down here. The graph doesn't start until 0. And it includes 0, and it goes up forever. So both the domain and the range for this one are 0 to infinity. And the last graph that we're going to look at is the absolute value graph. So f of x equals the absolute value of x. And this graph basically looks like a great big capital V. And it cuts this, the first quadrant and the second quadrant, exactly in half. So this line is basically the line y equals x, and this line is the line y equals negative x. Okay, so to get other points on here, you could just go up one, right one, up one, right one, up one, right one. Here you go up one, left one, up one, left one to get other points. Okay, and then the domain. So it goes to the right and left forever, so that's negative infinity to infinity. And the range starts at 0 and goes up forever. So 0 to infinity. Okay, so those are the graphs. So you need to have these shapes memorized. Also a good idea if you have these patterns memorized so that you can use the pattern to find additional points for those graphs as well. Okay, so our first example, we're going to take a look at a square-root graph. So we're going to use the graph of f of x equals square root of x, which we just saw, and we're going to get the graph f of x equals x plus 2. So we're adding 2. It's outside of the square root, and so that means that we're shifting up or down, and because it's positive, we're going to be going up 2 units. So instead of having my starting point at 0, 0, I need to shift that up 2 units. So it's going to be right there, and you can use the pattern. The pattern was to go up 1, right 1, and then up 1, right 3. And then don't forget when you're graphing to label your points. So we have 0, 2, 1, 3, and 4, 4. And then example B, so this is using the absolute value. This is the one that looks like the big capital V. This minus 2 is on the outside, and so that means that we're going to go down 2 units. So in the graph that we looked at above, the starting point or the bottom of the V was at 0, 0 here. We need to shift that down 2 units, so it's going to be at 0, negative 2. And again, you just go up 1, right 1, up 1, right 1 to get a bunch of points on this. And then up 1, left 1, up 1, left 1. So we have the point 0, negative 2, and this is the point negative 1, negative, positive 1, negative 1. And then 2, 0. And over here we have negative 1, negative 1, and negative 2, 0. And again, don't forget to label some points on your graph, however many they're asking you for. In our next example, another absolute value graph. This time the minus 2 is inside of the absolute value, and so that means I'm shifting to the right or the left. This goes opposite of what we would normally think, and so a minus 2 means that I'm going to go right 2. So the bottom of the V is going to be right here, and again, just go up 1, right 1, up 1, right 1 to get some other points, and then up 1, left 1, up 1, left 1. And don't forget to label your points. This is the point 2, 0, and then we have 3, 1, and 4, 2. And over here we have the points 1, 1, and 0, 2. Okay. And down to our next one. So again, another absolute value graph. This time we have a plus 2 inside. When we had a minus 2 inside, we went to the right 2. So a plus 2 inside means we're going to go left 2. And so the bottom of the V will be right here at negative 2, 0. And again, just go right 1, up 1, and then left 1, up 1 to plot some points. So we have the point negative 2, 0 as the bottom of the V, and then we have negative 1, 1, and 0, 2, and then this is the point negative 3, 1, And here we have the point negative 4, 2. And now our next example. So this time there's a couple of things going on here. So we have a negative 2 inside. Negative 2 inside means we're going to go right 2. And the positive 1 on the outside means that we're going to go up 1. Okay, and this is the quadratic graph, so it's the one that looks like a big capital U, and the bottom of that big capital U is going to be right 2 and up 1, so that's going to be at the point 2, 1. We'll put that back in black. And then you can use the pattern, and the pattern for this was that you go right 1, up 1. And then from there, from this point, you're going to go right 1, up 3. So 1, 2, 3 right there. And then again, we go left 1, up 1, and left 1, up 3 to get the other 2 points. And then make sure that you're labeling all of these. So we have the point 3, 2, and 4, 5. And over here we have the points 1, 2, and 0, 5. Okay. In our next graph here, again, we have a couple of things going on. We have a plus 1 inside, or underneath our square root, and since it's plus 1, that means we're going to go left 1. And then we have a minus 2 on the outside, that means that we need to go down 2. And it's the square root graph, so that was the quadratic graph or the x squared graph on its side. And so we want to go left 1 and down 2. So that's going to put my starting point right there, and you can use the pattern from here. So we would want to go up 1, right 1, and then up 1, right 3. So we have the point negative 1, negative 2, 0, negative 1, and 3, 0. And now for some reflections. So this negative sign that we have right here is basically what you would want to call on the outside. And so that meant that it was an x-axis reflection. In order for it to look like it's inside, there would have to be parentheses around it and being squared, so this would be an inside or, excuse me, a y-axis reflection. Okay, so this one is on the outside though, so it's going to be an x-axis reflection. And so we're going to take the big capital U-shaped graph and just flip it upside down. And you can use the pattern, go right 1, down 1 instead of up, and right 1, down 3 instead of up 3. And do the same thing, left 1, down 1, and left 1, down 3. So we have 0, 0, 1, negative 1, 2, negative 4, negative 1, negative 1, and negative 2, negative 4. And this is just the absolute value graph, same thing. Instead of opening up with a big capital V, it's going to be a big capital V opening down. Labeling some points, we have 0, 0, 1, negative 1, and 2, negative 2. And we have negative 1, negative 1, and negative 2, negative 2. Couple more left to do here. Next we have a a transformation using the square root graph. And so we have g of x equals negative square root of x minus 2. So we have the negative sign out front. That means we're going to flip over the x-axis. And this minus 2 underneath or inside means that we're going to go right 2. So right 2 is right here, and then we can use the pattern. It's just that instead of being up here, the graph is going to be down here. So we would go down 1, right 1, and down 1, right 3. So we have the points 2, 0, 3, negative 1, and 6, negative 2. And something that we haven't been doing is stating the domain and the range. So the domain on this one, x's start at 2 and go up to positive infinity. So that would be 2 to infinity. There isn't any graph over here. And then the range. So this graph goes down forever, so that's negative infinity. And it stops at 0. But includes 0, so we use a square bracket. And this is another one using the x squared graphs. That's the one that looks like the big capital U. We have a couple of transformations here. We have a negative 1 on the outside. That means that I'm going to go down 1. And I also have a minus 2 on the inside. That means that I'm going to go right 2. So we're going to go right 2 and down 1, so right there. And this is the x squared graph, so it's the one that looks like the big capital U, and you can use the pattern. Right 1, up 1, right 1, up 3. And then left 1, up 1, and left 1, up 3. And labeling our points, we have 2, negative 1, we have 3, 0, and 4, 3, and over here we have 1, 0, and 0, 3. The domain for this, so this goes to the left forever and to the right forever, so it's negative infinity to infinity. The range, the very smallest it could be is negative 1, and it includes negative 1, so we use a square bracket there, and then it goes up forever, so that's positive infinity. And the domain and range on this graph. So the domain, it goes to the left forever and to the right forever, so that's negative infinity to infinity. And then the range, so it's down here forever, so that's negative infinity. And it doesn't go up forever, though it stops here at 0. And it includes 0 right there, so we use that square bracket. And the domain and range of this one, same as the last one that we just did. This one goes to the right and left forever, so negative infinity to infinity. And the range, so it goes down forever, so that's negative infinity, but it stops right here at 0. And it includes 0, so we use a square bracket. So this graph goes to the left and the right forever, so the domain is negative infinity to infinity. And the range, so it starts at 0 and goes up forever. And we use a square bracket because it's including 0 here. Domain and range of this one. So the x values start at negative 1, and it goes to the right forever, so off to positive infinity. And the range, it starts down here at negative 2, and it goes up forever, so negative 2 up to positive infinity for the range. domain negative infinity to infinity for both the absolute value graph and for the quadratic graph. So both of these will always be negative infinity to infinity for the domain. Range is either going to be from negative infinity up to this point if it's opening down, or it's going to be from this starting point up to positive infinity. So this range is going to be from 1 to infinity. And domain negative infinity to infinity. And the range is from 0 to infinity. And the last two here. Domain on this one, so it starts at x equals 0 and goes up forever. So 0 to infinity. And the range, the y values, it starts at positive 2 and goes up forever. So 2 to infinity. And domain here, again, negative infinity to infinity. And the range, it starts at negative 2 and goes up forever. So negative 2 to infinity. Okay, that's it for our lecture on stretching and reflecting of the graphs of functions. Let me know if you have any questions. Thanks.